Namaste students. Now we are going to see equation of line in space. So a line is uniquely determined if it passes through a given point and has a given direction, and the next one is it passes through two given points. Now we are going to see two forms of the equation. One is the vector form and the other one is the Cartesian form of the equation. So the first one is equation of a line through a given point, means it passes through a point and parallel to a given vector b vector. So the vector equation of a line that passes through a given point whose position vector is a vector and parallel to a given vector b vector is given by r vector is equal to a vector plus lambda b vector. This is the vector equation of a line passing through a vector a vector and parallel to a vector b vector. Next one is the Cartesian form. Equation of a line through a point x1, y1, z1 and having direction cosines L, M, N is given by x minus x1 by L is equal to y minus y1 by M, which is equal to z minus z1 by N. This is the equation of a line passing through x1, y1, z1 and the direction cosines L, M, N. And similarly, if the direction ratios are given, a, b, c are the direction ratios, then x minus x1 by a is equal to y minus y1 by b, which is equal to z minus z1 by c. So these two are the equations of a line in the vector form and the Cartesian form passing through a point and parallel to another vector. So this is the vector equation and this is the Cartesian equation of a line. The next one that we are going to see is vector equation of a line passing through two points whose position vectors are a vector and b vector is r vector is equal to a vector plus lambda into b vector minus a vector. This is the vector equation of a line passing through two points, and the Cartesian equation of a line passing through two points is given by the two points are x1, y1, z1 and x2, y2, z2. That is x minus x1 by x2 minus x1, which is equal to y minus y1 by y2 minus y1, which is equal to z minus z1 by z2 minus z1. These are the vector and the Cartesian equation of a line passing through two points. Okay, so now you learnt the vector equation of a line passing through one point and parallel to another vector, and this is the Cartesian form, and here it is the vector equation of a line which passes through 2 points, and this is the Cartesian equation of a line which passes through 2 points. Now coming to the angle. Now angle between two lines. If theta is the acute angle between the two vectors, r vector is equal to a vector plus lambda b1 vector and r vector is equal to a2 vector plus lambda b2 vector, then the angle between the two lines is given by cos theta is equal to modulus of b1 vector dot b2 vector divided by modulus of b1 vector into modulus of b2 vector. This is the angle between two lines. Now the same way, if the lines are given in the Cartesian form, x minus x1 by a1 which is equal to y minus y1 by b1 which is equal to z minus z1 by c1 and x minus x2 by a2 which is equal to y minus y2 by b2 which is equal to z minus z2 by c2 are the equations of two lines, then the acute angle between them, it is given by cos theta is equal to modulus of a1 e2 plus b1 b2 plus c1 c2, where a1 b1 c1 and e2 b2 c2 are the direction ratios, divided by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. This is the angle between the two lines. Okay. The next one, exercise 11.2. So it is given here, show that the lines with direction cosines to 12 by 13 minus 3 by 13 minus 4 by 13 and 4 by 13, 12 by 13, 3 by 13 and 3 by 13 minus 4 by 13 and 12 by 13 are mutually perpendicular. So these are the direction cosines of three lines and you are asked to prove that they are mutually perpendicular. So two lines with direction cosines L1, M1, N1 and L2, M2, N2 are perpendicular to each other if L1, L2 plus M1, M2 plus N1, N2 is equal to 0. Okay, so now what are the direction cosines of the first two lines? 12 by 13 minus 3 by 13, 4 by 13 and 4 by 13, 12 by 13, 3 by 13. So this is L1, M1, N1, L2, M2, N2. So just substitute here. So 12 by 13 into L2. So which is 4 by 13 plus minus 3 by 13 M1 into M2 12 by 13 plus N1 minus 4 by 13 into 3 by 13. So when you take the product, this becomes 48 by 169. This is minus 36 by 169. This is minus 12 by 169. So minus 36 minus 12 is minus 48. So plus 48 and minus 48 it becomes 0. So these two lines are perpendicular. Now when you consider the next two lines, you have the next two lines, that is this one and these two direction cosines. When you consider these direction cosines, so you get, just take the product again. So you get 4 by 13 into 3 by 13 plus, here this is 12 by 13 into minus 4 by 13 plus 3 by 13 into 12 by 13. So when you take the product, this becomes 4 3s are 12. 12 by 169 minus 48 by 169 and here it is 36 by 169, which becomes 0. Okay, so these two lines are perpendicular. Next you consider the first and the last set of lines. So you have here 3 by 13 into 12 by 13, then minus 4 by 13 into minus 3 by 13 plus 12 by 13 into minus 4 by 13. So when you multiply, this becomes 36 by 169 and here it is plus 12 by 169 and this is minus 48 by 169. So 36 plus 12, 48. 48 by 169 minus 48 by 169, which is 0. Therefore, the lines are mutually perpendicular. So the lines are mutually perpendicular. Okay, now moving on to the second one. So the second one, it is given here. Show that the line through the points 1, minus 1, 2 and 3, 4, minus 2 is perpendicular to the line through the points 0, 3, 2 and 3, 5, 6. Now, there are two lines. One line passes through these 2 points and the other line passes through these 2 points. So, let us assume, let AB be the line joining the points 1, minus 1, 2 and 3, 4, minus 2. And let CD be the line joining the points 0, 3, 2 and 3, 5, 6. Now first let us find the direction ratios. So the direction ratios A1, B1, C1 of the line AB are. So we are going to find the direction ratios of the line AB joining these 2 points. So how do you find the direction ratios? The direction ratios are given by x2 minus x1 comma y2 minus y1 comma z2 minus z1. So here this becomes 3 minus 1 comma 4 plus 1, minus of minus will become plus, minus 2 minus 2. So the direction ratios are 2, 5 minus 4. These are the direction ratios. Okay. Next one, the direction ratios A2, B2, C2 of the line CD are. So of the line CD, when you take, you have to consider these 2 points here. So when you consider these 2 points, what do you have here? This becomes 3 minus 0, then 5 minus 3
and 6 minus 2. So this is 3, 2 and 4. So these are the direction ratios of the line joining the points these two. Now what are you asked to prove? You are asked to prove that these are perpendicular. So AB and CD are perpendicular to each other if and only if the sum of the product of their direction ratios are 0. So now A1 into A2 plus B1 into B2 plus C1 into C2 should be equal to 0. Now what is A1, B1, C1? This is A1, B1, C1 and this is A2, B2, C2. So just multiply that. So you will get 2 into 3 plus 5 into 2 plus minus 4 into 4. So 2 3s are 6 plus 5 2s are 10. Minus 4 into 4, 16. So 16 minus 16 which is equal to 0. Therefore, AB is perpendicular to CD. Okay. Now the next one, the third sum. Show that the lines through the points 4, 7, 8, 2, 3, 4 is parallel to the line through the points minus 1, minus 2, 1 and 1 to 5. Now let us write, we need to prove it as parallel. When will you call two lines are parallel? As if they are in the same ratio. If the ratio of the direction ratios, if you take, it should be equal. So let AB be the line through the points 4, 7, 8 and 2, 3, 4 and CD be the line through the points minus 1, minus 2, 1 and 1 to 5. So now we are asked, we have to calculate the direction ratios of the line AB. Okay, so we have to find the direction ratios. So how will you find the direction ratios? Just subtract 2 minus 4. So you'll get 2 minus 4, comma 3 minus 7, comma 4 minus 8. So the direction ratios are minus 2, minus 4, minus 4. Next, to find the direction ratios A2, B2, C2 of CD. So CD is the line joining these points. So when you take, you will get 1 minus of minus, it becomes plus 1. Then 2 minus of minus 2, so it is plus 2. And 5 minus 1. So you will get this. Now this becomes 2, this is 4 and this is also 4. Okay. Now AB will be parallel to CD if A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So what is A1 by A2? This is A1 minus 2 by 2. So minus 2 by 2. What is B1 by B2? Minus 4 by 4. Minus 4 by 4. What is C1 by C2? Minus 4 by 4. So it is minus 4 by 4. What is this? Minus 1. This is also minus 1. This is also minus 1. So you got here A1 by A2 is equal to B1 by B2 which is equal to C1 by C2. Therefore, the lines are parallel. Okay. Now, the next one, the fourth question. You have find the equation of the line which passes through the point 1, 2, 3 and is parallel to the vector 3i plus 2j minus 2k. Now it is given that the line passes through the point 1, 2, 3. So the position vector through the point A of 1, 2, 3 is nothing but A vector is equal to, just write this in the vector form. So which becomes I plus 2j plus 3k. This is A vector. So vector equation of a line passing through A vector and parallel to B vector is given by R vector is equal to A vector plus lambda B vector. So what is A vector? We have this. And B vector is nothing but, this is B vector through which it is parallel. So therefore the vector equation is, you got A vector I plus 2j plus 3k plus lambda into what is B vector? This parallel vector. So which is 3i plus 2j minus 2k. So this is the vector equation of the line passing through the point 1, 2, 3 and parallel to this vector. Okay. Now moving on to the fifth sum. So the fifth one, it is given, find the equation of the line in vector and in Cartesian form. Both you have to find. Okay. passes through the point whose position vectors are. So the position vectors are given and the direction is given. Okay. So here this is A vector and this is B vector. You need to write that. So what is A vector given here? So A vector is given here as 2i minus j plus 4k. Okay, and B vector is I plus 2j minus k. Now vector equation of the line is r vector is equal to A vector plus lambda B vector. So which is 2i minus j plus 4k plus lambda into B vector I plus 2j minus k. Okay. Now the Cartesian equation of the line, it is given by, so whenever you take the Cartesian equation, you should write r vector is equal to xi plus yj plus zk. So xi plus yj plus zk is equal to, just combine this. So 2 plus lambda into I cap, okay, and here you have plus minus 1, the coefficient of j is minus 1, plus 2 into 2 lambda into j cap. Then here you have plus, what you have here, 4 minus lambda into k cap. So just compare this, the coefficients of I, j and k. Okay, so from this, how will you write the Cartesian equation is, the Cartesian equation is x minus 2 divided by 1, which is equal to y plus 1 divided by 2, which is equal to z minus 4 divided by minus 1. So the points which passes through, so 2, here it is plus 1 and minus 4, and the direction cosines, the vectors 1, 2 and minus 1. This is the Cartesian equation of the line. So this is the vector form and this is the Cartesian form. Now moving on to the sixth sum. See the sixth one. Find the Cartesian equation of the line which passes through the point minus 2, 4, minus 5 and parallel to the line given by x plus 3 by 3 which is equal to y minus 4 by 5 which is equal to z plus 8 by 6. Now you are asked to write the Cartesian equation of the line passing through this and parallel to another line. So now it passes through the point minus 2, 4 and minus 5. And it is parallel to the line. This is the line. So you know the Cartesian equation is given by x minus x1 by a which is equal to y minus y1 by b which is equal to z minus z1 by c. So here x1, y1, z1 are the points through which it passes through, and a, b, c are the direction ratios which is given in this line. Okay, so therefore the equation is x minus of minus, so plus 2 by, what is a here? A is 3, which is equal to y minus 4 divided by b is 5, which is equal to z minus of minus will become plus, this is c plus c. That is all. Okay. Now the next one, seventh one, it is given the Cartesian equation of a line is x minus 5 by 3 plus which is equal to y plus 4 by 7 which is equal to z minus 6 by 2. Write its vector form. So the Cartesian form is given, you have to write the vector form. Okay. So from this you can see very well that the point through which it passes through x1, y1, z1 are nothing but it passes through. So if it is minus, here it is plus 5. So minus 4 and 6. Okay. The position vector of this point will be a vector is equal to 5i minus 4j plus 6k. Okay. And the direction ratios of the line are 3, 7 and 2. So the direction vector will be 3i plus 7j plus 2k. So the vector equation is of the form r vector is equal to a vector plus lambda b vector. So r vector will be equal to, this is r a vector now. So 5i minus 4j plus 6k plus lambda into, this is b vector. So 3i plus 7j plus 2k. So this is the vector equation of the form from the Cartesian form. Okay. Now moving on to the eighth sum. Find the vector and the Cartesian equations of the lines that passes through the origin and 5, minus 2 and 3. Now the line passes through the origin. So which one is the origin? The coordinates of the origin are 0, 0, 0 and 5, minus 2 and 3. Now the direction ratios of the line are, now you have to find the direction ratios. So how will you find the direction ratios? X2 minus x1, y2 minus y1, z2 minus z1. So here x1, y1, z1 are 0. So the direction ratios of the line are 5, minus 2 and 3. Okay. Now the line is parallel to the vector. What is the vector here? This b vector. This is the b vector. So 5i minus 2j plus 3k. So the vector equation of the line which passes through the origin and parallel to this vector are nothing but, so what is the vector? It passes through the origin. So r vector is equal to, this is 0 vector plus lambda into, what is b vector? 5i minus 2j plus 3k. This is the vector equation. Now the Cartesian equation is, it passes through this and the direction ratios are 5, minus 2 and 3. These are the direction ratios. So now the Cartesian equation is given by x minus x1 by a, which is equal to y minus y1 by b, which is equal to z minus z1 by c. So x minus, what is x1? 0 by a. What is a here? 5. And y minus 0 by minus 2, z minus 3 by 3. Sorry, z minus 0 by 3. So which can also be written as x by 5, y by minus 2 and z by 3. So this is the Cartesian equation of the line passing through the origin and another point. Okay. Now the next one. Find the angle between the following pairs of lines. Okay. So the lines are given in the vector form. R vector is equal to, this is one line and this is another line. Now you are asked to find the angles. Okay. How will you find the angle between the two lines if it is given in vector form? It is nothing but cos theta is equal to b1 vector modulus of b1 vector dot b2 vector divided by mod b1 into modulus of b2. So now let us see what is b1 and b2. So what is b1 given here? b1 is this vector. Okay. So b1 is 3i plus 2j plus 6k cap. Okay. b2 is I plus 2j plus 2k. Now b1 dot b2, take the dot product of these two. So which becomes 3 into 1 plus 2 into 2 plus 6 into 2. So which is 3 plus 4 plus 12. So what is this? 4 plus 3, 7. 7 plus 12, 19. This is 19. Now modulus of b1. So modulus of b1 is square root of 3 square plus 2 square plus 6 square, which is equal to square root of 9 plus 4 plus 36, which is equal to root 49, which is equal to 7. Now b2 vector, which is 1 square plus 2 square plus 2 square. So which is equal to square root of 1 plus 4 plus 4, which is equal to root 9, which is equal to 3. Now you have to find the angle. So just substitute here. So cos theta is equal to modulus of b1 dot b2 is 19 divided by 7 into mod b1 is 7. Mod b2 is 3. 7 into 3. So from here, which implies theta is equal to cos inverse of 19 by 21. This is the angle. Now the next one is, you are asked to find the angle between the following pairs of lines. Here it is given in Cartesian form and here it was given in vector form. So what is the Cartesian form angle? What is the formula to find the angle if the line is given in the Cartesian form? So if it is given in Cartesian form, cos theta is equal to whole modulus of a1 a2 plus b1 b2 plus c1 c2 divided by root of a1 square plus a2 square plus a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. Okay. So now what is a1, b1, c1? This is a1, b1 and c1. And here this is a2, b2 and c2. So first let us find a1, a2 plus b1, b2 plus c1, c2. So what is a1, a2? 2 into minus 1. So 2 into minus 1 plus b1, b2. 5 into 8 plus here it is minus 3 into 4. So when you multiply minus 2 plus 40 minus 12. So which is equal to 26. Okay. The next one, root of a1 square plus b1 square plus c1 square. So which is equal to root of, this becomes 2 square plus 5 square plus minus 3 square. So which is equal to root of, so when you square this you get 4 plus 25 plus 9. So which is equal to square root of 38. Okay. The next one is square root of a2 square plus b2 square plus c2 square, which is root of, what is a2 here? Minus 1 square plus 8 square plus 4 square, which is root of 1 plus 64 plus 16, which is square root of 81, which is equal to 9. So now we need to substitute all these values in this formula. You will get the value of theta. So from here what you get is cos theta is equal to modulus of, so this value is 26. 26 divided by root 38 into 9. So here theta is equal to cos inverse of 26 by 9 into root 38. Thank you.